you have an input in V3 to reset any fault. So usually customer wants to control everything from the field bus. He does not want any hard wiring. In that case, you can also reset a fault from the communication. Or if you want to reset the fault from any hardware input, you can do the parameterization and drive in group number 31 where you want to reset from. Then you have an input for auto start. So that is to re-trigger the bit 0 and bit 3, that is ready, and then run to automatically restart the drive. And then you have external control location, which means here whether you are controlling the drive from ext1 or in ext2. So in drive you have local mode and remote mode, and again in remote mode you have two control location. So where you want to control from, so that is from this external control. Four bits in the control word which is user defined, which can be used for your programming. And then the last input is the status word, where you will be reading the drive status word. Coming to the outputs of this block, so you have busy. If there is any error, you'll get an error, and then what is the error ID. And you also have an output which says no connection to drive. So in case PLC and drive are not communicating, then you get this no connection to drive as true. And then this ready operating on inhibited at set point, tripped, alarm, local control, all these are part of the 16-bit control word. And then you'll also get whether run enable input is on or off. And then here the control word what we are giving from PLC to drive can be monitored here, and here you'll get the any error message. So it will show tripped operation waiting for switch on command. Like this you can see the message from here and then give the commands. So like this, I hope you understood each input and output of this function block, which is very easy and self-explanatory. So another common block which we will be using is the scaling block. So DRV scaling, which is linked to the 46th group of your drive parameters. So with this, you can do your speed scaling, speed or frequency, and then the torque scaling, basically the reference. So we all know that in drives, the actual speed or the frequency scales from 0 to 20,000. So frequency 0 to 50 hertz is equal to 0 to 20,000. Similarly, speed 0 to 20,000 is equal to 0 to 1500. Coming to torque, 0 to 10,000 is equal to 0 to 100%. So this is how the, what do you say, sorry, this is how the scaling works, and this is the block to be used for the drive scaling. So during demo we'll see how this block can be used. So I can say this block works similar to your lintrafo if you have used in the PLC programming from the util library. So this performs the same functionality. So that was all about the overview of PS5604 drives library. Now let's see one by one protocol how to communicate PLC with our drives. So first we'll look on to Modbus RTU protocol. So in drives library, we have dedicated function blocks for Modbus RTU. So to control, to establish communication, we have dedicated blocks. Now, consider in a network, not only drives, there are other third party drives or third party devices available which are connected in loop or in daisy chain with the drives. So that time, how do you do? For all the drives, you will be using the drive Modbus RTU block, that is to establish communication, drive control Modbus ACS to start and stop the drive, and then the drive scaling. So like this, for each drive, one block you need to use. One block of each has to be used. So if you're having 10 drives, 10 blocks of this has to be used. Like this, you will be linking. In this block, there is an input called, it's both input and output, called line token. So it should be linked with all your drive blocks. Next, in case you're using any third party devices like energy meters or third party drives, other make drives, then you can use mod RTU must or mod RTU token. So again, you should use mod RTU token. You need to link this line token of your drives block to this other devices block. So in this way you need to link it. So like this you will have the connectivity in the programming. So again, when you're using drive control blocks for read and write and all, you need to link it with a input output parameter called drive data. So drive data should be common for all your one drive. Then again, the second drive blocks, it should be like drive data 2. So in this way, you need to establish the communication. So maybe once we start doing, you will be able to understand. Just give me a minute. So if you have any question, please feel free to type it in the chat. So now let's see with respect to the hardware what is required on PLC side as well as the drive side. So coming to the PLC side, if you're using AC500 V3 Eco, Modbus RTU terminals are not built in. You need to purchase an optional card which is TA5142 RS485 non-isolated or TA5142 RS485I, which is an isolated card. So this optional board should be fitted in any of the slot in the Eco PLC. So we see here it is fitted in the COM1. So if it is in slot 2, we call it as COM2. If it's slot 3, we call it as COM3. So in this, you have A1 and B1, which will be used for communication. So please note in PLC, A is positive and B is negative. And behind this optional board, there are some dip switches. There are 4 dip switches, which is used for bus termination and pull up pull down resistors. So here you can refer the help. So in when PLC is master or when PLC is slave, what should be the condition of this four resistors? Now we are using PLC as the master, so in that case all the four dip switches should be in on condition. So please do remember, on the PLC side when it is master, all the four dip switches should be set to on. Okay. In AC500 V3 standard, the PLC has inbuilt COM port, COM terminal, which is called COM1. In this, pin number 2 and 3 will be used for RS485 communication. 2 is positive and 3 is negative. So this is with respect to the hardware for Modbus RS485 in PLC. Next, coming to the drives. So as mentioned earlier, all the AC drives, latest generation drives, have onboard inbuilt Modbus RTU terminal. So when you see ACS 880 drive, the ZCU control card, this XD2D terminal is used for Modbus communication. So and also near this there will be some jumpers which has to be taken care for bus termination, term and bias. So if this is a last drive, only then this term and bias should be enabled, else all the drives from first to end or in between, it should be off. If you're looking at ACS 560 or 580 drives, then the lower frame R0 to R2, you will have this RIIO 0 1 card where this gray, usually the gray terminal block will be used for the Modbus communication. So in CCU 23, this gray and 24 here. So this is the position where Modbus RS485 will be available. And in 380, the BMIO01 card will have this gray terminal for Modbus. Please do remember in drives, B is positive, A is negative. So do not get confused. In PLC and drive, the polarities are different. In drives, B positive, A negative. In PLC, A positive and then B negative. So remember this and connect. In case you are confused or forgot, don't worry, just interchange it. So in case this built-in or embedded port is occupied for some other purpose, you can also have an optional card called FSCA01, which can be used for RS485 communication, which can be added in any of the slots. Okay. Now, let's see how to establish the communication between PLC and drive. So first, I will show the configuration in PLC side. Let's move on to the demo. So before that, I will enable your mics. If you have any doubts, please let me know. Your mics are enabled. If you have any doubts, please let me know. Okay, so if anyone have questions like a question like, will this drives library work only for ABB drives or even for other make drives? So this drives library is designed only for ABB make drives. Okay. So now I'll be sharing my screen to demonstrate the demo. So let me create the new project. So with me, I have AC500 V3 Eco PLC PM5032. Okay, so let me create a new project. So I have PM5032 TETH, and in that option card, TA514 to RS485 is added in the optional slot 1. So in option slot 1, let me add TA5142 to RS485. Okay. So if you're using AC500 V3 standard, you can see the serial interfaces COM1. Under that, you can directly add COM1 Modbus RTU client. Since here PLC is the master, under CA serial COM, add object and configure PLC as Modbus RTU client. So this procedure remains same whether you're communicating with ABB drives or third-party drives or any third-party devices. Then go to TA514 to RS485, double click. Here you need to configure your Modbus parameters. So in this case, the drive side baud rate is set as 19200 and parity is set as 8 even 1. So let me change it. Please ensure drive side and PLC side, this Modbus parameters, serial parameters has to be set same. Okay. Next, we need to design the do the programming. For that, go to library manager, add the drives library. So before I add the drives library, I want to show there are some sample project related to this library. So where can you access from? Just go to help, project examples. It will take you to a path. There you can see this PS5604 drives folder. Open this. So for all these protocols, you have a documentation and parameter backup of drive as well as PLC. Okay. So I have ACS 880 drives with me. So I can open the parameter and just show it to you. Okay, by the time we open, let's go back to the automation builder. Go to add library. So here ABB AC 500. Go to use cases. Under drives, you need to add the drives library. So this library is applicable for all the protocols. So you can see your drives library is added. You also need to add the Modbus RTU library, the generic Modbus RTU library from under Modbus. So it's added. So you can see in the drives library what are all the blocks present. So when you go to function block, you have basic FBs, function blocks dedicated for CAN open protocol, dedicated for Modbus and for Profinet. So let's see for Modbus, you have these are all the function blocks. We will be using drive Modbus RTU to establish the communication, drive control Modbus ACS to start and stop the drive. So in case you want to read and write, so you can also use this drive Modbus write, drive Modbus read. For TCP/IP, we will be using drive Modbus TCP and then again drive control Modbus ACS. So when you click on this block, you can see the graphical representation and the documentation description of each input output. So you can go through from the library manager help. Okay, now let's start doing the programming here. Create a POU. So I will write it as drive Modbus RTU. Okay, then add the block. So first we need to use the, you can go to this three dots, go to the drives library, go to the function block, Modbus, use drive Modbus RTU function block. Okay, so here you can give the name for the function block and then enable. So this you can always keep it true to enable that function block. Next, COM. So in Eco PLC, in which slot you have added the option board. If it's slot 1, COM will be 1. Slot 2, COM will be 2. And slot 3, COM will be 3. In case of standard PLC, the inbuilt COM port will have COM 1. Then if you're using an extension board like CM5610RS, in that there are again two COMs. So you can number it as 2, 3, and if based on that as you increase you can give the COM number. So here I have added in slot 1, so I will give COM 1. What is this SERV server? So this is the node address of the slave drive. So in this drive set, whatever you give it as the node address in 58 group, you need to enter here. So say I will be giving it as 2, so I will enter here as 2. Timeout, it will be 1000 millisecond. I will keep it as default. Reconnect pause not required, priority not required. Enhanced profile. So in drives there are two profile, classic profile and enhanced profile. If you're using the onboard embedded port in the drive, please use classic profile only. So this enhanced profile default it will be false, so I will leave it as it is. Then if you're using enhanced profile, then this NVR read, NVR write will be applicable. So you can enter how many data you want to read and write. So you can enter like 10, 10. Then write values. So you can give a name for this. So this is if you want to write any values to the drive. Then which we discussed this in out parameter line token. So this is important if you are using multiple devices connected serially, where you need to link this line token of each device, then only communication will work. Then this drive data. So this again we need to use when you're linking the blocks of one particular drive. So in one drive you might use totally three blocks. One is to establish communication, another one is to control the drive, and the third one is scaling. So to link these blocks of one drive, this drive data has to be common. So if you're using the second set of drives, second set of blocks, so change this name and link it. Then outputs, I will delete all this question mark. So here read values, I will give the name. So this will be an array. So if you want any other outputs to give name to monitor, you can give. For example, this online will tell whether the drive is communicating or not. So this block alone is to establish communication. In case you want to control the drive, then you need to use another block. So which block is that? Drive Control Modbus ACS. For DC drives, you will use DCS. So this block is used to only control. If you're not doing control, you're only doing monitoring, then this one block is sufficient. So let's do now both read and write. So this is again to enable the block, switch on. I will leave it empty and monitor during the online. Then this is for the ramp commands, where you can give it as true. So if you've already done the Modbus communication with ABB drives, you would be knowing they will give a control word in a sequence like 1142, 1143, and 1151 in decimal. 1142 is for ready, 1143 is for stop, and 1151 is for start. So that exactly those commands are designed in this block. Okay. If you want to reset, you can reset. So speed reference, let me give a name and use it in scaling block. And this drive data, please do remember both the blocks are used for one drive only. Just copy and use the same variable here also. Then outputs, I will delete. So if you want to monitor anything in specific, you can give the variable and use it. So actual speed. So here you will get the status word. So here you can see the control word and message from here. So if it is drive tripped, you'll get here trip status. Okay, so like this you can create. So the third block we'll be using is the scaling block. So like this, for one drive, totally 3 sets of block will be used. So it is very simple. There are ready-made function blocks. You need to just parameterize them. As mentioned earlier, it has a speed scaling of 0 to 20,000. So speed scale max will be 20,000. And here, so this depends on whether your drive is in scalar mode or vector mode. In scalar mode, drive will be in frequency mode. So here you need to enter 50 Hertz. In vector or DTC, it will be in RPM mode. So I need to enter the maximum speed required. This should be equal to your 46th group in speed scaling. So in speed reference, Here you need to give the input how much you want to feed. And this feedback is the same parameter which you have used above. So you can copy paste. So whatever you get here will be the raw value in terms of 20,000 count. So if you're using torque reference, you'll do the scaling here 0 to 10,000, 0 to 100%. So here the speed feedback reference I will be using here. So whatever you feed in here, for example, you give 1500 here it will show the scaling in 20,000. So here you'll get the raw value, here you'll get the actual speed. So any doubt with respect to these three blocks? So you can unmute and ask if you have any doubts. So I am done with respect to programming on the PLC side for the drives. So now let's call that function block, sorry, program. Okay, so let me compile it. So there are no errors. Now let me log into the PLC. So before login, I will show you what are the drive parameters we need to set. So I hope my screen is visible. So in drive side, 58 group is used for the Modbus RTU. So I have an Excel where I have mentioned all the parameters for each drive for each protocol. So after the training, I will share that Excel also. You can follow it. 5801 will be none by default. So here I'm using 880 drive and taken the screenshot. This is applicable even for other all compatible drives also. So 5801 default it will be none. You need to make it as Modbus RTU enable. Then 5803 here you need to enter the node address. So in our case we will be entering it here as 2. Then baud rate 19200, the same thing we have used. Parity, you can choose which you want. So I will be using the default 8 even 1 only. Then once these are done, go to 5806, double click on this and refresh the parameter so that it gets saved. So this is very important. Another important parameter is 5815 communication loss mode. This has to be kept to any message. So default it will be control word ref1 or ref2. Please change it to any message. So these are all the parameters in 58 group to establish the communication. Next comes the data read and write. If you want to read any data or write any data. So you can see in 58101 up to 114, these are the parameters you can set for read and write. By default, 58101 will have control word 16-bit, 102 will have reference 116-bit, 103 reference to 16-bit, 104 status word 16-bit, 105 actual one. So till here, these are all the default parameters. So next from 107 onwards, you can configure what you want to read and write. For example, you want to read power or torque or DC voltage, you can go here, go to other and select the parameter. Similarly, you can configure all the parameters here. So 7 is for current, 1.7, 1.11 is the DC voltage. I think 1.14 is the power or power. Okay, so like this you can monitor. Please remember this bracket 16 and 32 indicate 16-bit and 32-bit. If it's 16-bit, consecutive parameters you can parameterize. If you're using 32-bit, you need to skip the next one and use the third one. So because for 32 it occupies two 16-bit registers. And another hint, So since you're using ABB Drive's AC500 PLC, ABB PLC, you don't need to remember the register address. In case you're using any third-party PLC, in case you want to give them the register address, simply remember 58101 is mapped to 40,001. 102 is mapped to 40,002 and so on. So what you configure here, accordingly you can view it in holding register 40,000 number. Okay, I hope this is clear. So, and in PLC, you can also create visualization for this two function blocks which we saw, drive Modbus RTU and then drive Modbus ACS. So let's see how to create that visualization also. So just to show here, 58 group. Okay, I do not have the cable here to connect actually, but as shown, these are all the parameters. So quickly I will parameterize in the drive so that we can log in into the drive. So apart from this, you need to do few more parameters apart from 58. If you want to start and stop the drive, and then you need to go to group number 2001, you need to make it as embedded field bus, and reference based on scalar or vector, you need to go to 2211 and make EFB ref1. Okay, so all these parameters I'll be doing, only that change is node address 2 and parity will be 8 even 1. So my parameterization is done. So now let's log in into the PLC. So before that, let's also complete the visualization part. So how to add the visualization? Right click, add object, visualization. So this is just for troubleshooting visualization. So it will take some time. Yes, visualization is added. So double click here, go to visualization toolbox. So here you will have ABB drives and then ABB Modbus AC500 Modbus RTU. So you need to use this ABB drives. So here, yeah. So drive Modbus RTU Visu. So here I need to link the FP instance. So ensure always it should be in the white part. Now let's take the control visu. Same, link the instance. Okay. So I'll just put this side by side. Okay. Now let me log into the PLC. So any doubt till here, anyone? Okay. I just recycle the power. We'll just wait for 2-3 minutes for PLC to reboot. So how many of you, quick question, maybe you can type it in the chat. How many of you have already used this library with Modbus and established communication? Whatever we saw now, drive Modbus RTU, drive Modbus control ACS. Can you type yes in the chat? How many of you have already used it? Have you faced any challenges? Okay, now let's log in. So termination is very important in Modbus RTU communication. So in PLC side, if you're using Eco PLC, there are dip switches available. If you're using standard PLC, you can use 120 ohm resistor for bus termination. In case of drives also, there are dip switches. Only for the last drive, you need to make the both dip switches on. So it will be, the dip switches will be nearer to the Modbus port itself. So yes, let's go to the program. So here you can see this online is true, which means communication has been successfully established. There are no any errors or warnings in the communication block. Now again in the drive control block, you can see there is an error message which says tripped reset drive. So just go to this reset input and you can reset. So you can give a variable and write that variable. So drive is reset. So here you can see wait for rising edge of switch on input. So for troubleshooting purpose, this message is very useful. So this is the switch on input. This is a rising edge. So I will switch on. So you can see here the control word, the drive is ready and it is ready to take the start command. Wait for run input. So I will give run. Okay. So you can see operation. Operation means drive is running. So here ready, operating and set point. For the set point, we will be using the drive scaling block. So here reference I will give as 750 RPM. So you can see you're getting the feedback as 750 RPM. So I will just show it in the chat that the drive is running. So you can see it in the chat I have put. We have given the reference 750 RPM and then the drive is operating at 750 RPM. So I can just show in the chat. So you can see we have given 750 and then the drive is operating at 750 RPM. I can now increase the RPM to 1200. So you can see the speed is gradually increasing. So what you get here is the raw value and this parameter should be used for your actual value. So if you want to stop, just use this run input to stop. So the drive has been stopped. You can see the speed is ramping down to 0. Again, you want to start, you can start. Okay, so now during running conditions, say I create some fault like STO fault. I'll just remove the looping of the STO terminals in the drives. So you can see the drive has tripped and you're getting the message here. So let me reconnect the STO terminals. Now I need to reset the fault. So here, once you reset the fault, this also has to be on and off. Okay, so this I'm showing directly, but you need to create a logic. Whenever there is fault, these two inputs has to be reset again. Okay, so again when I start, drive will operate. Okay, so this is how very easy to communicate ABB drives and ABB PLC. So here you will get the status word. So this is the control word which I told you 1151. In case it's in hex, it's 47F. Okay. So this is all about Modbus communication with AC500. So let me stop it. Any doubts? So we have completed the first protocol, AC500 with Modbus RTU with drives, ACS 880 drive. Any doubts? So I see the today people are very silent and not so interactive. Any doubt? Okay, I will enable your camera. So quickly turn on. Let's see how many of you are actively listening. So quickly turn on your cameras. I have enabled. Please turn on your cameras. Turn on your cameras quickly. I can see only like 10 people have turned on. Are you able to understand what I'm showing regarding the drives? Yes, no? So your mics are enabled. You can unmute. So you can give thumbs up if you're able to understand, or thumbs down if you're unable to understand. Yes or no? Yes, please turn on your camera quickly. Nice, nice, nice. Very nice. Good to see all of you. Great. So, do you want a break or shall we continue next protocol? Today, people are very silent. Okay, let's take one snap. Everyone, smile. You can give a thumbs up. Quickly, quickly. Lovely. Thank you. So, you can turn off your cameras. We'll take a 10 minutes break and we'll be back at 12:10. So, before that, let me talk about good practices in and then complete this session on 485. Oh, okay. I forgot to show you the visualization, right? Yeah, coming to Visu. So from here also you can get all the details. Okay. So presently the drive is in stop mode. Wait for run input message. So I can start also. So you're getting operation and you can see the actual speed here in raw values. Okay. Now I just want to stop. I can stop it. So you can see here operation is false. Again I start. Operation is true. So you will have the scaling block also, I think. So you can, yeah, we have the scaling block as well. So that also can be utilized. So let's log in. So here I can see the scaling also. I can change the reference here. Say I give 1400. It's not allowing to write from this block. Okay, this is not allowing to write. So you can see here. Okay, so in this way you can utilize the visualization as well. Okay, so let me stop it and then log out. So the last slide for this topic of Modbus RTU, some of the best practices that we need to take care while using RS485. So We know that it's a serial bus communication. There will be some signal reflections. In order to avoid signal reflections, you need to use 120 ohm resistor termination for bus termination on both PLC side and the drive side. So as we discussed on PLC side, Eco PLC will have dip switches which should be used, and on standard PLC you can use a 120 ohm resistor for end termination. In case of drives, each drive will have these jumper settings which need to be enabled. So you can see the first and the last drives, you need to enable this term. Okay. So this is all of the last drive you need to enable. Then always it is recommended to lay this Modbus RS485 cables away from your power cables, and you need to use a twisted pair shielded cable only. And also if you're using communication adapters, please fasten the grounding screw properly. So these are some of the best practices or some inputs that you can follow in order to avoid Modbus communication loss. Okay. So, so the next topic will be AC FANET V3 and drives connectivity over Modbus TCP/IP. Before I move on to this topic, let's have a small break for 10 minutes. So if you have understood the first protocol, it's same and similar for the rest of the protocol. Just some parameterization or the blocks will differ. Okay, so let's break for 10 minutes and we'll be back at 12:10.